All right, everybody, let's see a hand calculation of correlation and regression all the way to the end where we plot the line. We can even go ahead and figure out the beta weight and R squared. That way we can see all of the steps involved in this process. So what do you need? Well, you need data. I have data. I'll show you that in a second. You need some paper, you need a pen, you're going to need a ruler for your tables and for your graph. I would get out a calculator. You can use them on your phone or computer as long as you know how to use your calculator. That's all that matters. And I'm going to get out some highlighters because I find it to be particularly useful when tracking my data across the tables. So let me get all this out of the way and let's start the problem. All right. So first thing I'm going to need is going to be a table for all of my data. Right, so I'm going to start out up here. I have X data and I have Y data because we're doing a correlation, which means I'm going to need X. I'm going to need X minus the mean of X, X minus the mean of X squared, Y minus the mean of Y, so on and so forth. Okay, so let's go ahead and label what we need first. So X is one of our columns. X minus the mean of X is another column that we're going to need up there. Then we're going to need to square that column. X minus the mean of X squared. Then we can do the same thing with our Y data. Remember, we need this last step because this is part of the numerator of our correlation coefficient. Okay, there are 7 data points here, right? So n equal to 7, which means we need 7 rows. So 1, 2, 3, 4, 5, 6, and the last one, 7. We'll leave those hanging down there. Okay, so our data now. The X data represent the percentage of market share of Internet Explorer. So the percentage of all of the web browsers that were being used in a given year, what percentage of that was Internet Explorer instead of something else like Chrome, let's say. So in 2006, that number was 87%, but by 2007, it was down to 77%, and as we moved through the years, it went to 75, 66, 61, 51, and finally in 2012, the market share was down to 43%. These data actually came from Wikipedia, so I'm not vouching for their authenticity, it's just sample data. The Y data then, this is going to be the rate of murders in the United States as a function of 100,000 of people. So it's per 100,000 people. So in 2006, the rate was 5.81 murders per 100,000 people in the United States. It dropped to 5.70. This went to 5.43 to 5.03 to 4.76 to 4.71, and then a slight increase back at the end to 4.73. Okay, those are our data, so if you need to, pause the video, write those down, get your table set up, and then let's move forward. Okay, so now what we want to do is sum these data so that we can get a sum of X. And I'm, just for the heck of it, going to switch to a different pen here and see if we can get this one to show up nicely and color code this a little bit so it's easier to see. So if you add all these together, it's going to add to a sum of 460. Actually, you know what? I'm going to go back to the other pen because it's a little bit more bold. I want you guys to be able to really see these lines. All right, 460. Now, I told you that there was a sample size of 7, right? So 460 divided by 7, our X bar is equal to 65.71. All right, so I'm going to draw a little box around that because that's an important number. Now what we need to do here is subtract off that value. So 87 minus 65.71, 21.29. All right, now we have to square these values, so squaring each of those, make sure that looks like a 6. All right, so we finished all that. These are our squared deviations, which means this is sum of squares x. All right, so if we add all of that up, we're going to get a 1421.4. Always add it up twice. I've done that already, so I know. That's why I put these double checks there. All right, and now we have another one of our important numbers. Okay. Now we can go ahead and figure out standard deviation and variance of x really quickly because we're going to need that later anyway. Remember, variance of x is equal to sum of squares x over n, which is equal to 1421.4 over 7. And so the variance of x is equal to 203.06. Standard deviation of x is equal to the square root of 203.06, which is equal to 14.25. So, again, important number. I'm going to block it off to the side there. Right, 14.25. Okay, now let's do the same thing for y. So add all of these together. Your sum is going to get to 36.17. Okay, divide that by 7, and you'll get y bar equal to 5.17. Again, another important value. Put it in a box, make sure I can see it. Now let's do y minus y bar, right? Taking this minus this to get that. We would then have, let's see, 0.64. Then we square all of these values. All right, now we have to sum all of those up. All right, so our sum of squares y is 1.35. Right. Now we got that value as well. So let's do this. Let's get our standard deviation of y. First, get variance of y equal to 1.35 divided by 7, which is equal to 0.19. So then the standard deviation of y is the square root of that value, would give us a 0.44. Alright, so we've got a good bit of what we need. Now we need these data. Okay, look, before we even move on, I'm going to do a couple of things here. First, I want to highlight all the important stuff so I can find it really easily later. Alright, now I've got those values. Now, this is going to involve multiplying this times this, and I don't want to get distracted or tripped up somewhere. So what I'm going to do is take another highlighter and highlight the columns I'm using. That allows me to keep a track as I go across. Okay, so now multiplying 21.29 times 0.64 will give us 13.63. Now, remember our correlation coefficient requires us to sum these values. So the sum of all of these will give you 40.68. Do it again, right? Double check to make sure it's right. And now we can go on with our correlation coefficient. So I'm going to go ahead and get a new piece of paper for this one. So let's start here. Correlation coefficient is R is equal to sum of x minus x bar times y minus y bar, right? We did that before. That's what we just did right here. So we can write that over to 40.68, right? That's divided then by the square root of sum of squares x times sum of squares y. Remember, we have sum of squares x, we have sum of squares y. So we can fill that in there as well. So that's divided then by square root of 1421.4 times 1.35. Okay, now we can solve this through the rest of the way, right? So that's a fairly easy process there. Let's do it step by step though, so let's do the bottom first. So 40.68 over square root of, this simplifies down to 1918.89, so that's these two multiplied by each other. Now we can do the square root of that. 40.68 divided by the square root of this, which is 43.81. This gives us a 0.928, or a correlation coefficient of 0.93. All right. Now, let's use that to figure out our slope as well as our y-intercept, so we can figure out our regression equation. Okay, so again, I'm going to get a new sheet of paper here. Y-intercept. Remember, y-intercept, if you think about it, it's when that line's going through, it's when x is going to be equal to 0, right? It crosses here, for example, and then x is 0. Or it crosses here, and then x is 0. So, y-intercept is when x is 0, and that's the value we're trying to figure out, right? Remember, in our regression equation, y equals a plus bx. Our y-intercept is a. So it's a that we're looking for here. And the way we're going to do this is with our z-score formula. So we're going to take a z of x, we're going to set x equal to 0, we're going to subtract off the mean of the x data. Remember, that was 65.71. Divide then by the standard deviation of that data, 14.25, and that'll give us a negative 4.61. We now need to find the z of a predicted y from that, so we multiply our correlation coefficient times the value we just got, and we get a negative 4.29. Lastly, we want to use our y data to go back from a z of y to a regular y, so a y of hat would be equal to negative 4.29, that's z of y, times the standard deviation of y, 0.44, plus the mean of y, 5.17. Remember, these are the data we calculated earlier, so just look back at the other sheet of paper. Run all that through, you get 3.28, which means our y-intercept is 3.28. Okay, now slope. Slope is b. We need 2 points for that, so we're going to do another point, 1 and something. All right, so we go through the steps again. Z of x now is equal to 1 minus 65.71 divided by 14.25. You get a negative 4.54. Z of y hat then, 0.93 times negative 4.54. Right? This will give you a negative 4.22. Y hat then gets that back out of the z-score world or back into the raw score world. Plus 5.17. That will give us a 3.31. Now, slope then is easy to calculate. Right, it's rise over run, so it's y2 minus y1 divided by x2 minus x1. Well, that's easy. Gives you 0.03, which means our regression equation then is y is equal to 3.28 plus 0.03x. All right, so we've created our regression equation. Now, let's do two more quick things, and then let's graph it as well. Okay, so I'm going to carry this over here so that we can see it. Y is equal to 3.28 plus 0.03x, and our correlation coefficient is equal to 0.93. One thing we want to do is figure out our coefficient of determination, or proportion of variance accounted for. Remember, that's just r squared, so 0.93 squared is going to give you a 0.86. So according to this, not only are the usage of Internet Explorer and murder rates positively correlated, and strongly so, the proportion of variance in murder rates that's explained solely by Internet Explorer market share is upwards of 86%, which means out of all the possible explanations for changes in murder rates across the United States across this period of time, changes in Internet Explorer account for 86% of that variability. So pretty impressive, especially if you've ever used Internet Explorer. You can kind of understand why you might be led to murder after having used it for a little while. Okay, so that's r squared. The other thing we want to do is calculate beta, right? Our beta weight is our standardized slope, so that's our existing slope, b, times the square root of sum of squares x over the square root of sum of squares y. Remember, again, we've already figured out all of these data, right? We have sum of squares x, we have sum of squares y. Let's just plug it in then. We know that b is 0.03. Multiply that times the square root of 1421.4 over the square root of 1.35. All right, so again, let's just carry it through step by step. That would be 0.03 times 37.70 over 1.16, which would be equal to 0.03 times 32.5, which is then equal to 0.98. So our beta weight is equal to 0.98. All right. The very last thing I want to show you is how to use the regression equation to plot your line on a scatter plot. So we need a scatter plot. All right. Get out a sheet of paper. Get out a ruler. And draw some axes. Alright, I got a y-axis, I got an x-axis. Now, because my x data range from 43 to 87, I'm going to mark 40 at the low end, 90 at the high end, and just go 50, 60, 70, 80, and say that looks pretty close to accurate. And my y data range from 4.71 to 5.8, so I'm going to go from 4.0 up to, let's say, 6.0. Put 5.0 in the center, 5.5 up here, and 4.5 down here. This is murder rate. This is percent market Internet Explorer. All right, now we need to go back to our raw data, right? So these data in X, these data in Y. So our first data point is an 87 and a 5.81. So 87.5.81. So 87 would be roughly out here. All right, we can use our other piece of paper to sort of estimate roughly where 5.8 would be. And let's say it's about right there. Right, so darken up that dot. Next point would be 77 and 5.7. So we'll go down to roughly about 77. We'll come across here to about 5.7. And we'll place a dot right there. Next one is 75 and 5.4. So we just go a little bit down. Same here, we just go a little bit down. Next we got 66 and 5.03. And then 61 and 4.76. And then 51 and 4.71. And 43 and 4.73. All right, and that is our scatter plot, right? You can darken up those dots so that they're super visible. And this one over here. And now, let's talk about how we can use our regression equation on here. So, y is equal to 3.28 plus 0.03 x. It's useful if you pick some x's that are already in your range here. So I'm going to pick a spot for 40, right? And I'll say when I plug this in for 40, right? So put 40 in for x, solve that through. Y would be 4.48. So that would be 40, comma 4.48. So roughly here. I'll do that again then for 90. If I do it for 90, I get 90, comma 5.98, which would be all the way down here and all the way at the top, so pretty close to about right there. So I've got my 2 points really just by plugging in those two values into the equation, and now I draw the line. My ruler's not quite long enough. Yeah. And there we go. Correlation, regression, beta weight, slopes, y-intercepts, all the fun stuff. Oh, r-squared too. So that's it. Watch it again if you have to. Slow it down as many times as you have to. Practice it. Do the homework. If you can do all that, you'll be ready for the exam, no problem. All right, cheers.